Hey, physical science. We're going to be talking about atoms and isotopes this week. So I've just got a few examples to get us started. Um, all right, to jump in, an atom is basically the smallest unit of an element. Okay. Basically, if you had a little sample of, say, carbon and you kept dividing it and dividing it and dividing it, you'd basically get down into smaller and smaller pieces until you got to a single atom. And then if you divide that any further, you're breaking down protons and neutrons, and it's no longer carbon. So, atom is the smallest unit. It's made of protons, neutrons, and electrons. Okay, those are called subatomic particles because they're smaller than an atom. A proton, right, positive charge, and a neutron are found in the nucleus of an atom, and an electron is found in an orbital. And a good way to visualize an atom would be to draw, say, like, let's do an atom of carbon. An atom of carbon typically has 6 protons and 6 neutrons in the nucleus, which would be the center of an atom. Okay, and then outside, somewhere in this region outside of the nucleus, you'll find 6 electrons. Now I'm just going to kind of just randomly put them in here. I think that's 6. Each electron, right, carries a negative charge, and they're going to be found away from those positive charge. Now they're in constant motion. Um, they might be found in certain regions of that cloud, more so than other regions. But let's just think of them as outside. Now, electrons are really small compared to protons and neutrons. So the mass, okay, the mass of this atom basically comes from the nucleus. So the nucleus comprises like over 99% of an atom's mass. Okay, and the electrons are almost negligible, right? We're going to round them to 0 atomic mass units compared to protons and neutrons, which each have about 1 atomic mass unit or a mass of 1 atomic mass unit. And so together, the mass number is equal to the number of protons plus neutrons. So in this case, we call this carbon 12 because there's 6 protons and 6 neutrons, which add up to carbon 12. Okay. Well, additionally, right, you can have a different form of carbon. Carbon is element number 6, so it's always going to have 6 protons, but sometimes you find a nucleus of carbon that contains 8 neutrons. So I'm going to put again 6 dots in here. 1, 2, 3, 4, 5, 6. So there's our atom of carbon, except this time the mass number is equal to 14. 6 plus 8. So this we call carbon, 14. Now carbon 12 and carbon 14 both have 6 protons, okay? And they're the sixth element on the periodic table, right? You've got hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen. Okay, what this is, okay, these atomic numbers, carbon is number 6, this tells us the number of protons in each element. Okay, so hydrogen is the simplest of all elements. It's first on the periodic table. It has 1 proton. Okay, helium is the next largest, etc. You keep building up, and carbon has 6 protons. Okay, and both of these examples of carbon have 6 protons. That's what makes carbon carbon. However, one of them has 2 additional neutrons. So instead of having 6, carbon 14 has 8. So we say that this is the heavier isotope. Okay, oops, my pen is cutting out. So let's see if it comes back. Heavier isotope. And this would be the lighter isotope. Okay, so isotopes are the same element, just with different masses, and that's due to the number of neutrons in them. So let's try another one. Let's take, let's say, calcium 40. Okay. So calcium 40, if I asked how many protons, neutrons, and electrons are in calcium 40, well, calcium is element number 20. So I go find on my periodic table, and here I'm just looking at, sorry, I'm looking at a chemistry textbook. I've got a periodic table behind me also, so I guess I could refer to that. But calcium is element number 20, so it has 20 protons. Okay. I know that protons plus neutrons have to add up to this mass number, which tells me how heavy the nucleus is. Well, in this case, 20 plus something has to equal 40. So 20 plus 20 adds up to 40. So I know that there's 20 neutrons. Okay, and then electrons, for now, because we're going to be talking about what are called neutral atoms, the number of protons and the number of electrons, so the number of positive charges and the number of negative charges, are always the same in a neutral atom. So 20, 20, 20, right? Now, if we change this up a little bit and we make, say, calcium 41, which would be a heavier isotope, the number of protons is still 20, but now the number of neutrons is 21, okay? And the number of electrons is still 20, okay? Let's go the other way. Let's say I give you, oops, let's do this, protons, neutrons, and electrons. Let's say I give you 15, 16, and 15. Okay, so what element is this and what's its mass? Okay, so element number 15. I go to the periodic table and I look up for the atomic number 15, come across, it's in the third row or the third period. This is phosphorus. So phosphorus hyphen. Now I need to figure out how heavy this phosphorus is. Well, protons and neutrons in the nucleus make up the mass. So I just add protons and neutrons, I get phosphorus 31. Okay, phosphorus 31, right, has 15 protons and 16 neutrons, and protons and electrons are always equal, so 15 and 15 in this case. Now, sometimes we're going to get what's called an ion, and an ion will have different numbers of protons and electrons. So let's give another one. Let's go with protons, neutrons, and electrons. Let's say 17, 18, and 18. Okay. So what element is this? Well, I go a little bit past phosphorus, right? That was element 15. Element 17 is chlorine. Okay, so I know that this is chlorine because there's 17 protons. Okay, I know that 17 protons and 18 neutrons make a mass number of 35. So this is chlorine 35. And this is a little different than just chlorine. This actually has one electron more than it has protons. So in this case, if I have 18 negatives, so negative 18, plus 18 positives, that's 17 positives. That's 17 protons. Well, that adds up to -1. So what we say is this chlorine has a charge of -1, right? And we list that. This is called an ion. And we say that this is its charge. And that it's a negative ion. Okay? And we know that its mass number is 35. A lot of times we write the mass number up in the upper left-hand corner. And if we really want to go overboard, we can say that this is element number 17. So chlorine has 17 protons. This specific isotope has 35, a mass number of 35, and it has a charge of -1. Okay, so do one more for you. How about let's go with oxygen. Let's do... Okay, so oxygen with a mass number of 17, an atomic number of 8, and a charge of -2. Well, how many protons, neutrons, and electrons are in oxygen? Okay, this oxygen. So for protons, again, I go look up, this is element number 8. This tells me that, that there are 8 protons. It's the 8th element, starting from the top and working down and across on the periodic table, right? So it shows up here. Okay. To find neutrons, I know that protons and neutrons together have to add up to 17. So in this case, I can do 17 minus 8 to get 9. So there are 9 neutrons. Okay, and in this case, the overall charge is -2. So that means I need to have more negatives, more electrons, okay, in my atom than I have protons. So I need to have 2 extra electrons to add up to -2, so I'm going to put 10. You can double check, right? -10 plus +8, and -10 plus +8 adds up to the charge of -2. So I have 8 protons, 9 neutrons, and 10 electrons in oxygen. Okay, so there's a little on isotopes, a little bit on ions. I was about ready to wrap up, then I'm thinking maybe we should do a positive ion. Let's do one more. Sorry. Let's do a weird one, an obscure one. So this is sodium, Na. All right, and it's weird that it's starts with N, and it's sodium. Okay, but let's say it has an atomic number of 11. It's got a mass number of 23, and it has a charge of +1. Okay, so protons, neutrons, and electrons. Okay, protons, the atomic number is 11, right? Because it's the 11th element. I know that 11 plus 12 has to add up to 23. So total protons and neutrons in the nucleus is 23. And then, because the charge is +1, I know that I have one more proton than I have electrons. So I have one additional positive charge compared to my negative. So in this case, I only have 10 electrons. Okay, so, and you can double check. +11 plus -10, right? Because 10 electrons, that comes out to +1. And that's the charge. Okay, so I've gone through a few examples. Hopefully this video helps get you going. We'll talk about it in class, and I hope you guys have a good week.